Latin squares are simply square arrays of length n where each cell can have one of n distinct values. What sets a Latin square apart from a regular square array is that every element appears exactly once in every column and in every row. A Latin square can be easily identified by checking every row and every column and ensuring that each element appears exactly once in every row and in every column. This is an example of a Latin square. Every element is also color-coded to visually demonstrate the non-repeating nature of a Latin square's rows and columns. Latin squares are used in statistics when designing experiments. Latin squares allow less runs of experiments to be performed while still providing useful data. The usefulness of Latin squares in statistics becomes very clear when an experiment that makes use of Latin squares is shown. A good practical example of Latin squares would be their usage in agricultural research. Let's say we have 4 different types of fertilizer we would like to test. We could find 4 different fields, plant the same crop in each, and then use one fertilizer per field. The problem with this approach is that the fields themselves might have different nutrients, soil quality, or other environmental factors that may affect the final crop. A way to account for this variability is to use Latin squares. Instead of getting 4 different fields, one for each fertilizer, we could simply get one field and treat the field as a Latin square. We would section off the field into separate smaller fields, and then we would randomly assign the fertilizer to each smaller field in such a way that every column and every row has no repeated fertilizers. This would allow us to test every fertilizer 4 times while minimizing variability between the crops. The resulting data will allow us to fairly compare each fertilizer's performance. This is a fantastic example of the usefulness of Latin squares in real life. This application is very useful to chemical engineers and agricultural engineers. Latin squares are also used in cryptology or encryption. 2 Latin squares which are mutually orthogonal with each other may be used in conjunction with a lookup table to generate an encrypted message. Mutually orthogonal Latin squares, or moles, are simply Latin squares that if they were to be superimposed, then the resulting array would have a unique value in every cell. Let's say you want to send a message to your friend, but you don't want anyone to find out what the message is. You and your friend can construct 2 moles of length n along with a square lookup table of length n with different letters in each cell. To send the message, you would then spell out the words letter by letter using the corresponding coordinate points given by the 2 moles. Let's say you have the shown moles along with the shown symbol table, and you want to send the letter I. You would see which values appear in the same place as the letter I appears and send those values instead. The values that appears in the same place in the left moles is 3 and in the right moles is 2. So instead of sending the letter I, you would send the ordered pair 3, 2. To decode 3, 2, you would simply check which position would have a 3 in the left moles and a 2 in the right moles, and see which letter occurs at that position in the lookup table. This can be done with much larger moles to allow for more symbols. This application of Latin squares provides an easy to implement type of encryption which is very safe as long as the moles are kept secret. This application is relevant to computer engineers, computer scientists, and mathematicians.